Good day, students. This is number 7 of the 1973 AP Calculus Multiple Choice Review, problem number 12 of our Fundamentals Review series. So let's take a look at the problem 7. It says, which of the following equations has a graph that is symmetric with respect to the origin? So what does it mean for a function to have a graph that is symmetric with respect to the origin? Symmetry with respect to the origin is just another way of saying a function is odd. Okay, so let's go ahead and write this down. Symmetry with respect to the origin means that the function is odd. Okay, so what does it mean if a function is odd? If a function is odd, that means that f of negative x is equal to negative f of x. This is what it means for a function to be odd or symmetric with respect to the origin. There's another type of symmetry, which is symmetry with respect to the y-axis. That is, that means that the function is even, and in that case, f of negative x is equal to f of x. All right? We are dealing with odd functions here, so let's focus on using this equation to test to see which of these functions are odd. Okay, so let's start with option A. So for option A, the question is f of x, is f of negative x equal negative f of x? Is that the case? If that is the case, then the function is odd. Okay? So what we're going to do, we have the function f of x equals x plus 1 over x. We're going to substitute x with negative x and see if we end up with the opposite of this function. All right, so let's go ahead and evaluate this function when x is equal to negative x. So we're going to have negative x plus 1 over negative x. Now if we divide the numerator by negative x divided by negative is going to be positive x, and positive 1 divided by negative is going to be negative 1 over x. And this clearly is not negative x plus 1 over x. Okay? It's not the opposite. So that clearly shows that option A is not odd. Okay? So if it's not odd, that means that it is not symmetric with respect to the origin. So let's advance to option B. We have this function, negative x to the fifth plus 3x. Just by inspecting this function, we can clearly see that it is odd because we have a linear combination of two odd functions. So more likely than not, this will be odd. What do I mean by a linear combination of two odd functions? Well, inspect the powers of these two. This has a power of 5, which is odd, and this has a power of 1, which is odd. So more likely than not, this should be the correct answer. But we can't make any assumptions here. We have to show it rigorously that that's the case. So for option B, we are still asking the same question. What is the question? Is f of negative x equal to negative f of x? If I substitute negative x for x in the function, do I end up with the opposite of the function? So f of x is negative x to the fifth plus 3x. So f of negative x means we'll simply substitute negative x with the x's, so we have negative x to the 5th 5th, plus 3 times negative x. Let's go ahead and simplify that. This yields negative. If you raise negative to the fifth power, it's still negative, so negative x to the fifth. Minus times plus is minus, minus 3x, which is equal to x to the fifth minus 3x. Now, if I factor out negative from these two terms, this is going to yield negative. If I factor out negative from a positive term, it's going to become negative. The sign switches. And if I factor out negative from a negative term, it becomes positive. Now, if you take a look at this result, what is this? This is the opposite of the original function. This is equal to negative f of x. So that shows that this function is odd. Okay, it's odd or symmetric with respect to the origin. So the answer to number 7 is option letter B. Okay? Thanks so much for taking the time to watch this presentation. We really appreciate it. Feel free to subscribe to our channel for updates to other cool tutorials such as this. If you have any questions about this lesson, feel free to include it in the comments section below. We'll be glad to address it as soon as possible. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.